Alright guys, so I did highlight a few questions on the test review that I just wanted to briefly go over. So number 4 says, what percent of the energy is stored by an organism and available to be passed on to the next trophic level? Okay, so when we are moving from trophic level to trophic level, we are always giving, oh Lord, always giving 10% of the energy. Okay, so we are always passing on 10%. And so what happens to the rest of the energy? Well, the other 90% is going to be used in the form of heat. Okay, so it's lost as heat, or it's used up in life processes. And when I say life processes, what I'm referring to are stuff like metabolism or cellular respiration. Anything that our cells need energy to do, okay? Number 5 says, what do the arrows in a food web or chain represent? Okay, so the arrows are going to represent the flow of energy. Okay, so who is going to be obtaining that energy? We would be pointing the arrow towards that organism. Okay, so for instance, if I have grass, okay, and I say a caterpillar is eating the grass. Well, the caterpillar is the one that's going to be receiving the energy. So I'm going to draw an arrow in the direction that the energy is flowing. Okay, number 7 says, what would cause an increase in predator population? Okay, so this one could have multiple answers. And so one way that you could cause an increase in predator population would be to get rid of competition. Okay, so rid of competition. If you have nothing competing for resources with you, well then you could have all the resources you want, and so that would cause predator population to thrive. Okay, also if you were to write an increase in the prey population, then that also would cause predators to increase as well. Alright, moving on. Number 12 says, all the energy in a food web is provided initially by what? Okay, just remember, all energy begins with the sun. Okay, so you have the sun. The sun's going to give energy to our producers. And then our producers will then be consumed by our primary consumers and so forth. And then that's how we get our energy flowing through our ecosystem. All right, number 13 says, what is a limiting factor? And so a limiting factor is going to be anything that is going to prevent a population from growing. Okay, so anything that limits population growth. Okay, and so that is the biggie with that one. Alright, and again, limiting factors, for example, would be things like competition or lack of resources. What else? Diseases. Okay, so anything that's going to prevent a population from getting bigger would be a limiting factor. Alright, so I went ahead and turned it over right here on page 20. If you are still confused about 18 though, I did put a PowerPoint on Canvas, so you can go ahead and click through that. Otherwise, you should have taken a picture of the key for that portion in class. Alright, number 20 says, on what trophic level would you find the greatest amount of biomass? Okay, so always at the bottom do we have the greatest amount. Okay, and so whether I'm talking about biomass, energy, number of species, it's always at the bottom, okay? And then again, remember, for trophic level, the bottom is always trophic level 1, and as we move up, we increase our numbers, okay? So always trophic level 1. Alright, 25 says, what happens to a population when it reaches carrying capacity? Okay, so if we go way overboard on our carrying capacity, remember carrying capacity is going to be that maximum number of species that we can have in our ecosystem, and we could still sustain it, meaning we have enough resources that that population could still survive. And so if we go over the carrying capacity, so we have more organisms than we could actually carry, that means we're going to have less resources. And so if we have less resources, well then your population is going to die. Okay, and it's going to die because there's not enough resources to sustain it. And so it will drop right back below carrying capacity. And then once it gets to a certain level, we would see some growth in our population again. Alright, 27 says what would happen if an organism in the nitrogen cycle is removed? Okay, so if we were to remove, for instance, bacteria. Okay, if we removed bacteria from our nitrogen cycle, well, by doing so, we can't fix nitrogen. And so if we can't fix nitrogen, that means that a lot of plants and a lot of animals would die. Okay, and so pretty much our flow of nitrogen would be disrupted. Okay, and so if it's disrupted, organisms would no longer get the nutrients they require. Okay, so pretty much if you take any organisms out of the cycle, it's going to cause a huge disruption, and so you wouldn't see a lot of the organisms being able to function properly. Alright, so let's go ahead and turn it over. And so I'm right here at the bottom with the different symbiotic interaction examples. And so I'm going to do a few of them, but I think majority of y'all understand symbiosis pretty well. Alright, so again, we have 3 types of symbiotic interactions. We have parasitism, we have mutualism, and we have commensalism. And just to briefly review with you, remember for parasitism, one is going to benefit, it's happy, while the other one is getting harm. Okay? In mutualism, both of them are benefiting from this relationship, so they're both happy. They both get something out of it. Okay, and then commensal. One is benefiting, one is happy, and the other one doesn't really care. Okay, it gets no benefit, but it's not being hurt either, so it's just like meh. Okay, not really worried about it. Alright, so our first example, it says a tapeworm lives in the intestines of a dogfish shark and derives nourishment from the shark. Okay, so a tapeworm is living in the shark and it's taking nutrients from it. Okay, so the shark is going to be at risk for, being weak and possibly getting some type of illness. Okay, and so tapeworm in this case would be a parasite, okay, because it's taking nutrients from the shark and making the shark ill. Okay, next example says an oxpecker feeds on ticks found on rhinos. Okay, so the oxpecker is going to be getting a free meal, feeding off of the ticks on rhinos, and rhinos are getting a free grooming, okay? And so they're getting rid of those parasites that are found on their bodies. And so this would be an example of a mutualism. So they're both benefiting from that relationship. Alright, next one says silverfish live and hunt with army ants and they share the prey. Okay, so silverfish live with the army ants and the army ants are getting some help with hunting and they both are getting meals. Okay, sounds like a win-win situation. And so that would be another case where we have a mutualism. Alright, last one, we have mistletoe extracts water and nutrients from the spruce to the spruce tree's detriment. Okay, so I highlighted the word detriment because I wasn't too sure if everyone understood what that word meant. And so detriment means that it is causing harm or damage. Okay, so the tree is actually being harmed from this relationship. And so the mistletoe is getting nutrients and the tree is getting, hurt. And so that would be an example of a parasitism. Alright, so you should be able to finish off the rest of them on your own. So I'm going to go ahead and turn to the very back page. And I'm not going to go through all of this table, but I will do the first one for you. And so 34 says, if the producer in an ecosystem were to start out with 30,000 calories, write how many calories would be available at each subsequent trophic level. So I'm starting off with 30,000 calories. And remember, as we move from trophic level to trophic level, we only take 10%. So every time you go down, you are only taking 10%. So you would expect your numbers to get smaller and smaller as you move down the level. Okay, so here I have my producer. It has 30,000 calories and it is eaten by a primary consumer. And so only 3,000 calories will get passed down, and the other 90% will be used for its life processes or be getting rid of in the form of heat or waste. Okay, also if you're not comfortable with the whole calculating what's the 10%, the easiest way to do so is to just basically cross off or drop a 0 every time you move down. And so I'll go ahead and show you with the next one. I have primary consumer. It has 3,000 calories, and so when it's consumed by a secondary consumer, that consumer is only going to get 300 calories. And so every time you move down the trophic level, you will drop a 0. Okay, and that will give you your 10%. And so you should be able to do the last one on your own. And then if you want additional practice, you can try doing the quaternary and see how much it would get right there. Alright, last for number 35, it says for the following food web, label each organism with its consumer level. Many will be more than one and its trophic level. Many will be more than one. Then fill in the chart. So I'm not going to go through the entire thing with you, but I am going to label some of them so you understand how to read the food webs. Okay, so again, first thing we want to do is to identify our producers. And so I have grass. Grass is a producer. Shrubs. And I have a tree. Okay, and so easiest way to just remember producers are going to always be your plants. And I know in class we talk about fungi being a decomposer. That is true. However, sometimes some organisms do eat our mushrooms. Okay. Alright, once you've identified all of your producers, the next thing you're going to do is find those organisms that eat plants. Okay, and so just pick a plant to follow, and so in this case I'm going to follow the shrub. And so the shrub gets eaten by the rabbit. The way I know is I'm just going to follow the direction of the arrow. And so the rabbit would be a primary consumer, and I'm just going to write the number, we'll put first right next to it, so first for primary. The deer also eats the shrub, and the grasshopper, and lastly the squirrel. Alright, now that I've labeled all the ones that eat the shrub, I'm now going to move on and figure out what all eats my primary consumers. And so here I have my deer. Well, the deer only gets eaten by one organism, which is the mountain lion. So the mountain lion would be an example of a secondary consumer. Next, looking at the rabbit, it also gets eaten by the mountain lion. I have it labeled, so I'm going to skip that one. But it can get eaten by the snake. Okay? Next, I have the grasshopper. The grasshopper can get eaten by the insect-eating bird, or it's eaten by the shrew. And then last, I have the squirrel, and the squirrel gets eaten by the hawk. And so now I have all my secondary consumers. Okay, from there, you are then going to look at all your secondary consumers, and you're going to identify what organisms eat those. And so from here, I am going to start with the snake. And so the snake, I have my secondary consumer, and the snake can be eaten by either the hawk, but since this is secondary, that means the hawk could also be tertiary. And the snake can also be eaten by the mountain lion. So secondary, that means the mountain lion could also be tertiary. Okay, and then you would just do that for reading your food webs. Now, another trick I want to teach you with figuring out trophic levels when you have your consumers. So you have the rabbit. Rabbit would be a primary consumer, and the way I can remember I have the first right next to it. And so trophic levels, we always start with the producer, and then we count up. Okay? So if my producer here would be my first trophic level, that means my rabbit would be my second trophic level. Okay? If you're not familiar or comfortable with the counting of the different levels, easiest way is if primary means 1, when you're trying to find trophic level, you always add 1, and it'll get you your number. And so deer could be primary. And so 1 plus 1 would make it on the second trophic level. Here I have, let's see, trying to find one that has a higher level. So for instance, the mountain lion. The mountain lion can be secondary or tertiary. And so if I'm not comfortable with counting, I know secondary is 2, so 2 plus 1 is 3. Tertiary is 3, so 3 plus 1 is 4. So that can be a trick to help you figure out trophic levels. And just to double check the work to show you that that does work. So if I have the shrub, this is trophic level 1, the deer is trophic level 2, and the mountain lion eats the deer, making it trophic level 3. So that checks out. Okay, or I can say the shrub is trophic level 1, the grasshopper is trophic level 2, the shrew is trophic level 3, the snake is trophic level 4, and the mountain lion is trophic level 5. Oh, it would appear that we actually missed one. So not only could it be tertiary, it can also be quaternary. So I'll just put quat right there. So it could be trophic level 5 as well. And so if you just go ahead and go through, make sure you get them all, you should be okay. And then here at the bottom, you're going to do a similar thing to the one that you did before that. Alright, I hope this helps. If you have any questions, you can come to tutorials. But otherwise, good luck studying on your test.